Okay. Good evening. Can you hear me? Okay. Okay. Good. Okay. Starting from today, every Wednesday you have theory class. This time. Next Sunday also. Still can't hear? I think now okay. Can hear. Isuru. Take speaker. Okay, now okay, no? Others? Isuru? Okay. Fine. Okay. Starting from today, every Wednesday you have class, right? Every Wednesday. And starting from next month, Friday also you have class. Friday for first 3 months, 3 hours. After that, 4 hours. Right? Today, 2.5 hours. Wednesday. Okay. Now 2026 students now ET and BST first paper they did today. With the advanced paper, good level paper, right? Both papers. Some standard paper, right? That means standard means not too easy and not too hard. Medium level paper. Not too easy, right? Uh, they had lot of problems. They didn't have any enough time, right? Lot of problems they have, but paper is same standard. Paper का बहुत change करला ना. Then your guys also your paper more than advanced than 2026 paper, right? It bit advanced than 2026 because you don't have any problem. You have enough time and you are you have uh, recommended time. No, you have 2.5 years. Yes. Okay. This is our 13th lesson, I think. 13th or 12th lesson, kinetic chemistry. Last week we discussed completed thermochemistry. In thermochemistry lesson, we discussed mainly thermal energy, how involved for chemical reactions and how to calculate what heat of reaction. This background is disturbed. This one. It's good. Okay. In thermochemistry, we discussed about how thermal energy, heat energy involved for chemical reactions and calculate heat of reaction. Heat of reactions. I think you can remember we did heat of reactions with 5 main steps, right? It's very long calculation, right? Very long calculation. The final target of thermochemistry was calculate the heat of reaction. Same as this is our next chemistry lesson. It is kinetic chemistry. Kinetic chemistry. What's the final target of this kinetic chemistry is to calculate the rate of chemical reaction. This is a kinetic chemistry. Kinetic chemistry. Kinetic chemistry. Okay. Kinetic chemistry. In thermochemistry, we discuss about heat of reaction, how heat energy involved for chemical reactions. To react 1 mole of reactants, how much heat energy absorb or release. That's the meaning of heat of reaction. That's the final target of thermochemistry. Same as in kinetic chemistry, our final target, the rate of chemical reaction. Rate, not heat, rate of chemical reaction. What's the meaning of rate? Rate of chemical reaction. This is a final target, rate of chemical reactions. Chemical reactions. Now I told heat of reaction mean what? How thermal energy involved for chemical reactions, no? How much heat energy absorb or release. If it is exothermic reaction, heat absorb, endothermic heat exothermic reaction, heat release, endothermic reaction, heat absorb. How much energy absorb or release according to the reaction? Exothermic reaction, how much heat energy release to the surrounding while reacting 1 mole of reactants. That was the final target of thermochemistry lesson, right? To calculate heat of reaction. Samely, in kinetic chemistry, our final target to calculate the rate of chemical reaction. What's the meaning of rate? What's the meaning of rate? Yeah, the speed. Yeah, good. The speed. Actually, in kinetic chemistry, we're discussing how to calculate and what are the effect factors of and all background we're discussing everything. How to take place chemical reaction and how to increase chemical reactions with different factors. And finally, we discuss how to calculate, how to get a numerical value. Numerical value means number value for rate of chemical reactions with very long expressions. Okay, this part is the most important. It's a compulsory question, right? This more than thermochemistry, in kinetic chemistry, you have a lot of marks in exam because it's asking factors affect on rate of chemical reactions and how to affect these factors and how these how these factors change the path of chemical reaction, right? Everything of these chemical reactions and factors involvement and finally calculation, always every exam paper they are compulsory questions, right? That's why therefore this lesson very important. I'll explain in very simple level. Try to get full idea, right? Try to get the full idea. Hi. Okay. Did you collect the tune? Only 4 students inform me. Vihanga, you are very. Dinul, you met? You got. Dulen? Dulen got. Then only Vihanga. I got. Okay. So then Isru and Vihanga has problems. Okay, no problem. today part we can continue. Today part no space. I'll send PDF. Today, okay, right? Today part no spaces. I think in first part. Wait, I'll take. Today part no problem. Next tick we need Tute compulsory because we have some spaces to fill from this page. Okay, no problem. Wait, I will send the PDF. Okay, you can find the PDF. Okay, kinetic chemistry. Okay, everyone okay? Are you ready? Are you ready, Bhinga? Hi. Okay. As I told earlier, the kinetic chemistry mean it's a branch of chemistry. It's a branch. Mainly we discussing the rate of chemical reaction. The rate or speed of a chemical reaction. Speed of a chemical reaction. Normally, do you have some idea what's the meaning of rate of chemical reaction? What's the meaning of speed? How to measure the speed? Do you have any idea? Now we know the rate mean the speed. Then how to measure the rate of chemical reaction? How we can measure it? How we can measure this chemical rate of chemical reaction or speed of any chemical reaction? How we can measure? You meant any idea? How we can measure? Yeah, by dividing unit time. Yeah, that's a method of finding rate. What we can divide? මොනවද අපි divide කර? What we divide? Yeah, very good. Time it's take to convert reactants to products. Yeah, 20 to 30% correct, but it is not the exact definition, right? Yeah, very good. The concentration we divide, right? Concentration we divide. No, it is speed. Yeah, speed. Okay, distance divided by time. It's correct. But for rate of chemical reaction එකක speed එක. The speed of chemical reaction. Then the concentration change divided by time is the rate of chemical reaction actually. Okay, I will explain. I will explain in the next part. Okay, however, the rate of chemical, the kinetic chemistry mean it's a branch of chemistry that we discussing mainly about rate of chemical reaction or the speed of chemical reaction, right? Now, what we can use to identify a chemical reaction, or what are the evidence we can identify take place a chemical reaction in a whatever system? In a system, how we can identify, what are the evidence? What are the evidence? Okay, what you know, what are the evidence? Okay, I'll give you one example. It's releasing some, if it is some gas release, if you got a example, think it is HCl and magnesium reaction, magnesium, piece of magnesium, right? Then what happened? HCl and magnesium, it's produced magnesium chloride and hydrogen gas released to the surrounding. Then we can see it's air bubbling, air bubbling like this, air bubbling. Okay, it's a evidence. Then we can identify it's take place a reaction inside this test tube, right? Take place a reaction inside this test tube due to this evidence. Okay, what are the other evidence we can identify? We can identify take place a reaction. What else? What else? Done. Yeah, color change, very good. Color variation, color variation. Yeah, deposition particles that we call as form a precipitate. Precipitate kila kiyana? Precipitate. Very good. A temperature change. If it is exothermic reaction, we can feel some heat, temperature increase. If it is cold down, it is endothermic reaction, color change. Very good. Which part? Yeah, I told very simple thing. If you got HCl and magnesium chemical reaction, right? It's produced magnesium chloride and release hydrogen gas, right? Due to that, we can observe air bubbling. Due to this hydrogen gas released to the surrounding, we can observe it's air bubbling through the HCl solution, right? Air bubbling. This is an observation. This is observation. This is observation. Then we can identify a chemical reaction take place in this container. Chemical reaction take place in the system. I asked, what are the other evidences? We can identify a chemical reaction take place. Take place a chemical reaction. Safa, what else? It's very simple lesson. Don't take it very hard, right? It's very simple lesson. Yeah, you are correct. We can observe temperature difference and color change. Color change, formation of precipitation. Yes, precipitate, that means this chemical reaction, it's magnesium chloride is a solid. These solid particles precipitate these solid particles like at the bottom. It's precipitate. Yeah. Okay, I have given lot of evidence. Okay, color change, a clear difference in the color of the mixture. Okay, next, a formation of precipitate that we already discussed, a color change. formation of precipitate, and evolution of air bubbling. Just if it is released gas, if it is released gases product, we can observe air bubbling, right? Temperature change, if it is exothermic reaction, it is heated. If it is endothermic reaction, it's cooled down. Okay, change the odor, very good method. Change the smell actually, right? Change the smell, it's forming smell or odor, right? Due to different products. Change in state, that means change the physical state. Change the physical state, that means previous example, in as reactant we added magnesium particle, magnesium strip, that solid part, and HCl solution, right? HCl aqueous physical state. Yes, Dinul. Now example, right? Magnesium solid particle and HCl solution, right? But as product, මොනවාද product විදියට හැදෙන්නේ? Gases and hydrogen gas and magnesium chloride is a powder form. Then it's totally changed the physical state, right? Physical state also changing, right? Physical state change and change volume change. Volume change mean magnesium and HCl volume is not equal to product volume, right? Product volume sometimes very low amount, sometimes it is large amount, large volume, right? The volume of reactant or product that can be changed, and pH level and conductivity. If we measure the pH level and conductivity, we can see, we can observe some changes, reactants and product. Then we can identify a chemical reaction is take place inside the system. A formation of new substance. Yeah, it's a common thing. If it is chemical reaction, it's producing new things, new substance, new materials with properties different from the reactants. Yeah, that's the actual main thing. We can observe producing new things. It is not equal to the reactants. They are totally new characteristics, new things with new characteristics, right? Okay, they are the evidence. Okay, what are the main evidence? Main evidence are evidence to identify chemical reaction. Okay, what are they? Okay, first one, color changes. Okay, they are the main evidence, right? Color changes. What are the examples? What are the examples for color changes for chemical reaction? During a chemical reaction, the color will be changed, right? Example that you already know. If you got bread sample, bread mean starch, right? Starch. If we add iodine, what is the iodine normal color? What's the iodine color? Safa, what is the iodine color, normal color in liquid state? Do you know? With me? Not brown blue, it is brown color. Brown color. Okay, if it is add into starch, this starch and iodine react each other. These reactions I will explain in biomolecule lesson. React each other. Then it is converting to which color? Blue in color. Blue color when then initially it is brown color. Due to the reaction, it's convert to blue color. Blue color. Okay, they are the color changes. Then we can identify this bread sample contains starch. Contains starch. Oh, chemical reaction take place in the then also sometimes taken as no, I think. However, iodine solution is the one which we put. No, they are not iodine. They are not iodine. Iodine brown color. Iodine is brown color solution in laboratory, right? If we add into starch or any starch bread or any starch contain food or any substance, it's converted to blue color. Blue color. Okay, they are example for color change. Okay, color changes. Color changes. Okay, then temperature changes. That one also main evidence. Temperature changes. Temperature changes. If it is exothermic reaction, it is the surface or system become heated, increasing the temperature, right? Endothermic reaction, it's cooled down and decrease in the temperature, right? Then we can identify it's the chemical reaction is take place inside the vessel or inside the system, right? The third one, volume changes. Volume change, volume change. Volume changes. Reactant volume not equal to the product is producing new products. We can observe it's the product volume will be increasing, right? Then we can identify a chemical reaction is take place inside the system. Okay, the fourth one is the air bubbling. If it is some gas released as a product, we can observe as air bubbles, air bubbles, air bubbling. Air bubbling. Okay, they are the main evidence. Main evidence. Not only that, smell or odor. Odor. Smell or odor. And precipitation. Form a precipitation. If it is produced product as a powder, right? As in solid state producing product, it's deposit as a precipitate, right? Deposit as a precipitate that we call as a form a precipitation. Form a precipitation. 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 Okay. They are the main evidence we can identify a chemical reaction is take place in a vessel or system, right? Okay, then what are the advantages of this evidence? What we can get, our final target is find the rate of chemical reaction. Find the rate of chemical reaction. What are the advantage of them? Actually, by this evidence, We can't get exact idea. We can't get exact numerical value for rate of chemical reaction. But without calculating rate of chemical reaction, now rate of chemical reaction calculation process is very uh, advanced thing, right? We have to get some measurements, and we have to measure time to change concentrations, and it very hard thing, right? It's not an easy thing. But by this evidence, we can get some idea about rate of chemical reaction, right? We can compare and identify which if you got two reactions, example we can't get numerical value for rate of chemical reaction, but we can get some idea. We can get some idea about rate of chemical reaction. I got, we can get some idea about rate of chemical reaction by this evidence. I will explain it. Example, right? We have two test tubes. අපි හිතමු මෙහෙම two test tubes තියෙනවා. We have two same size test tubes, right? Okay, both contain magnesium and HCl, right? This is a magnesium plate and HCl solution. Okay, now if we label this is A and B, think A test tube, this is the air bubbling speed, but B test tube, this is the air bubbling speed. Okay, now we can compare. Now we can compare which reaction is higher rate of chemical reaction, A or B. Which test tube take place reaction with higher rate, A or B? A. Then we can compare and get some idea, right? We can get some idea about rate of chemical reaction. But the problem is, by this evidence, can we get a numerical value? අපිට ගන්න පුළුවන් the A test tube, the rate of chemical reaction 5 moles per cubic decimeter per second. No. Yes. We can't get a numerical value, but we can get some idea about rate of chemical reaction. Idea එකක් ගන්න පුළුවන්. If you want, we can compare and we can get some general idea, right? We can get some general idea about rate of chemical reaction by this evidence. Color changes, temperature changes, volume changes, from precipitation formation, and temperature changes, right? This evidence, we can get some general idea about rate of chemical reaction. Okay, this is the first thing you need to understand. Okay, from above evidence can be obtained some idea about, general idea about rate of chemical reaction, but can't get a numerical value for rate of chemical reaction, right? This is the first part, first basic things you need to understand. Okay, now according to this evidence, we can divide rate of chemical reactions. According to this evidence, we can divide chemical reaction into three main categories, right? Three main categories. බලන්න chemical reactions. Chemical reactions. Chemical reactions we can divide into three main subcategories, right? The first one is very slow chemical reactions. Very slow chemical reactions. right? The next one is the moderate rate, normal rate chemical reactions, normal rate chemical reactions, normal rate chemical reactions, very slow chemical reactions and normal rate chemical reaction. Then what is the final one? What's the final one? I have given very fast chemical reactions, very fast chemical reactions, very fast chemical reactions. Okay, now this very slow chemical reactions mean this chemical reaction take place sometimes several years to reactant convert into product, or several months, right? Many number of months or years, or sometimes several weeks to complete reactant to convert to product. They are very slow. Okay. Can you give me example for very slow reaction? Very slow chemical reaction. Can you give an example? Okay, what are the example? Yeah, rusting. Very good. Rusting of iron. Rusting of iron or corrosion. I, yeah. Yeah, a lot of examples. Human decomposition mean, Dinul? Human, yeah, paper turning to yellow mean, uh, paper turning to yellow mean paint decomposition, no? Paint decomposition. Paint decomposition mean paint chemical structure breakdown with time, right? Paint decomposition. Paint decomposition. Due to UV rays, especially UV rays and high sunlight, heat energy. Sugar fermentation to alcohol. Sugar fermentation to alcohol. That one also correct. Fermentation of sugar. Can we take, yeah, formation of fossil fuel? Fossil fuel formation, that one also chemical process. Fossil fuel formation. If fossil fuel formation. Do you know how to produce soil? Yeah, copper oxidation. Copper oxidation. Then you know copper wire convert into, with time they convert into dark color, not shiny color, right? Due to the oxidation. Yeah, process of diamonds. Yeah, very. Yeah, we can find lot of examples, right? Methana 100 ලියන්න පුළුවන්. Copper oxidation. Copper oxidation and what else? Do you know how to produce soil? Soil. Yeah, breakdown due to the breakdown of rocks. Yeah, rock breakdown also very slow chemical reaction. That one also chemical reaction. It's reacting with water and different chemicals in the earth, in the ground, in the soil due to organic acid. Different organic acid react with soil, react with rocks. Then it is converted into. It's a very slow chemical reaction. Sometimes take millions of years to break down, right? It's very slow chemical reaction. You know, Sigiri also, it's very slowly break down, right? ඒ කියන්නේ තව millions වගේ ඊටත් වැඩි වෙයි. යද්දී එහෙම එකක් නැති වෙයි. සීගිරිය කියලා එකක් නැති වෙයි. Right? It's very slow chemical reaction. It's very slow chemical reaction. Then rock breakdown. Rock breakdown. Okay, they are the examples, right? You can find more examples. I got only 5 main examples for very slow chemical reaction. It's very slow mean it's take more than years, right? Many years, more than number of years, right? It's very slow to convert reactant to product. It take long time, very long time, right? That's the meaning of very slow chemical reactions. If you got normal rate reactions, what are the examples? Normal rate reactions mean think of laboratory practicals. Yeah, boiling water. No, boiling water is not a chemical reaction. Nabil, we need only chemical reactions. Boiling water mean water convert into vapor. It's not a chemical reaction. Don't mix. Yeah, food digestion, very good. They are normal reactions within few minutes or with less than one hour. Less than 1 hour. Normal rate. Food digestion. Food digestion. What else? Dule. What else? What are normal speed reaction? මේව තමයි වැඩිපුරම තියෙන normal speed reactions. If you got acid base neutralizing reaction, is it normal speed or very fast reaction? Acid base reaction. Yeah, burning a wood. Okay. Photosynthesis, very good. Photosynthesis. 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 Making of plastic. Making of plastic. Yeah, that one also correct. Making of plastic. What is main? My question answer. if you got a neutralizing reaction, acid react with base, then it is exothermic or endothermic. Sorry, exothermic or endothermic. Normal rate or very fast. No, egg boiling is not a chemical reaction, Dole. We need chemical reaction. Do you know? First of all, you should have idea about what's a chemical reaction. Chemical reaction. Make it calling up chemical reaction. In next part we discussing chemical reaction mean reactants convert to product. Dole. Reactants convert into product due to a chemical change, chemical conversions. Product. Example, if you got A and B, they are reactants. The product is AB2. Reactant characteristic totally change with product characters. Product characters. Example, එකක් විදිහට මෙහෙම ගත්තොත් HCl plus sodium hydroxide, very simple example, then it is produced sodium chloride. Sodium chloride, you know, HCl and sodium hydroxide are the reactants. Then HCl is an acid, sodium hydroxide is a powerful base. Yeah, powerful acid. But the product is, it's a mineral, sodium chloride, neutral level, right? And water, right? No acid or base produced, right? Acid-base reaction. I got. They are the chemical reactions. Two or more reactant react each other and chemical changes. Doing chemical changes, it's produce new products, new compounds, new things. I got. Everyone? If it is chemical reaction, it's produce new things. If you got something boiling or something vaporization, they are physical changes, not chemical reactions. Correct? Clear, Nabil? Good. Dule? Yes. Then here. Yeah, the neutralizing reaction. Now it is a neutralization reaction. Yes. Neutralization reaction. Yeah, they are normal speed reaction, neutralizing reaction. That means all laboratory, then api lab එකේ කරන ගොඩාක් test, right? Laboratory test. All are normal speed reaction. Laboratory test. Laboratory reactions. Reactions. If you got respiration, suffer. Yeah. Isuru. They all are. Then acid, metal, acid base, acid water, all laboratory test. They are normal speed reactions, right? Normal rate reactions. Respiration. The respiration also normal speed reaction. Photosynthesis opposite side. Okay. Tell me, if I got petrol burning of petrol or diesel, normal speed or very fast reaction? Fossil fuel burn. Fossil fuel burn. Fossil fuel formation, it is very slow process. No. Fossil fuel burning. Fossil fuel burning is normal reaction. Yes. Fossil fuel burning is normal reaction. Remember, if it is very fast reaction, if it is very fast burning, in engineering technology you're learning, if it is very fast reaction, engine එක මොකද කරලා තියෙන්නේ? Directly supply fuel into cylinder, or it's convert into air fuel mixture. Yeah, it's convert to air fuel mixture, or a diesel නම් මොකද කරන්නේ? Using injector. Do you know? විහඟ ඒක කරාද? Using injector, fuels break down into very fine very tiny compounds, right? Like this. By injectors, may I inject එකක් කියලා? This fuel, මෙතනින් යන fuels, they convert into very tiny droplets. Then it is converted into very, actually, may I convert in a vapor එකක් පාට, petrol vapor or diesel vapor. This vapor burning is, petrol vapor burning is, that one is a very fast chemical reaction, right? Then fuel vapor burning, fuel vapor burn, fuel vapor burning is very fast chemical reaction. That's the purpose of carburate. Do you know carburate? One side provide air, in other side provide petrol, and there is a venturi tube. Do you know venturi tube? Venturi tube දන්නෝ? Yes or no? Venturi tube. Safa, do you know? Venturi tube. Okay, this is the mechanism of carburetor, right? This is the air filter. මෙතන දාලා තියෙන්නේ අපි sponge එකක්, air filter එකක්. Right? This is the air supply tube. Air supply tube. At the middle of this tube, it's become narrow like this. Air narrow, you know, right? Again, it's normal level, and provide, this is the cylinder, engine cylinder. This end is engine cylinder. මෙතන තමයි engine එක තියෙන්නේ, right? Engine cylinder. Engine cylinder. The burning take place in this inside the cylinder, pistons and everything working in the cylinder, right? This is a air supply system. This part we called as a venturi tube. Venturi tube. Okay, now air passing through this end, and at this middle narrow stage, what happened to the air speed? Is it increasing or decreasing? Now, V1 and it is V2. V1 or V2 is greater. Air speed yeah, V2. Then in a air very narrow tube, right? It's a very narrow tube with less thickness, less cross section area. Due to that, it's very fast compared to this stage. It is very fast. Due to that, this is a petrol tank. Petrol or diesel, right? Petrol tank or carburetor. Petrol tank. This petrol tank, the petrol line is supplied to this point. Petrol line is supplied to this point, right? Then due to high air speed, very fast air waves, the pressure of this point pressure, what happened? It's very low. That's we call as Bernoulli's theorem, right? This Venturi tube working according to the Bernoulli's theory, right? The pressure very low, but in the petrol tank, no air circulation, right? It's atmospheric pressure. That means pressure compared to pressure low. Sorry, pressure greater. Now it is low pressure area, right? Due to high air speed. Then what happened? High pressure to low pressure, the petrol transfer from high pressure to low pressure. Then due to this air speed, it's converted into air fuel mixture. Right? This air fuel mixture is supplied to the engine cylinder. That's why it is very fast chemical reaction. Without supply directly petrol into the cylinder, it's provide air fuel mixture. This is the purpose of carburetor. That's the function of carburetor, and it's provide air fuel mixture into the engine cylinder. Then it is very fast chemical reactions more than petrol burn. Understood? Okay. That we well make a කරනවා ඊටවලත් අපි මේක that we discussing in fluid mechanism under Bernoulli's theorem, right? Sorry. Okay. Then what else? Other very fast chemical reaction. Now you know lot of you can find many number of normal rate chemical reactions. What are the other very fast chemical reaction? Now petrol or fossil fuel vapor burning is very fast chemical reaction. What else? What else? Yeah, ignition of gunpowder. Yeah, that one also very fast chemical reaction. Yeah. What else? Acid related reactions. No. Acid related reactions, it's not very fast. They are normal. That means acid base reaction like that, no? No, they are normal reactions. It takes some time to reaction take place. Very fast reaction mean within less than 1 second reaction complete. Less than 1 second window. Yeah, explosions mean which? Okay, they are the very fast chemical reactions. Nucleic reactions, nucleic bombs, nucleic reactions, nucleic reactions. Nucleic reactions. This nucleic reaction has a huge energy. Nucleic reaction mean nuclear level energy, right? It's a very dangerous thing actually. Me the war, America and the Iran the main reason producing nucleic guns and bombs, right? It's a huge power and very fast chemical reactions. It's a chemical reaction. It's very fast. Due to this fast, it is very dangerous, right? Nucleic reactions. Nucleic reactions. What else? And atomic reactions. Atomic reactions. Atomic reactions. Atomic level reactions. Okay, that's enough. Okay, they are the examples. Now, according to the observations, previous observations, we can we can get some idea about rate of chemical reactions. According to that, we can divide chemical reactions into three main categories. They are the categories: very slow chemical reactions, normal rate chemical reactions, and very fast chemical reactions. Okay, you can note down them. I have given some data in Qt. I have given table. Uh, yeah, if you neutralize very strong acid and very strong base, that we consider as very fast reaction, but in laboratory level we not going to 100% acid and base react කරවන්න යන්නේ. එතකොට ඒක normal speed, but if we react 100% acid and 100% base, that can be a very fast chemical reaction. Okay, and moderate speed mean normal speed. මෙතන තියෙනවා ටිකක්. Reaction between zinc metal and dilute acid. Okay, they have normal laboratory reactions. Very slow chemical reaction, rusting of ions, weathering of rocks. Okay. Okay, if you want, I have given space here. No? I have given space here. You can note down. Okay, quickly note down. Okay, good. Yeah, that's the way you had to go. Do we have class on Sunday? Sunday, yeah, this month we can conduct, but next month I will inform that. Yeah, next Sunday you have class. After next Sunday, you don't have, I think. Yes. Okay, complete. No, we're not going to continue our Saturday class again. You know, we start final week of this month. Our revision. In revision class, we doing lot of papers. Don't worry. In revision class, we have another this our paper class. We did as a temporary class until start revision. In revision class, we have a separate paper program. Paper every day you have a simple paper, daily refresh paper. I will explain entire schedule. Revision date you asking? Yeah, still not finalized. I think we can get it Friday evening. Do you have class? You told you're free. The Q&A is free here. Yeah, everyone free Friday evening, Friday 6 to 10. Yeah, the Q&A will come. We start final week of this month. First day I will explain how you need to start working now. You have only 11 months. Within 11 months, I will give you to get each subject more than 90 marks before May. Within 11 months, I'll give you a super plan. Hi. Okay, the basic, very simple part is completed. Now we are going to lesson actually. It is not the lesson, very basic things we did. Okay. Okay. Now we are going to understand how a chemical reaction takes place. You know, I already explained what's the meaning of chemical reactants. Chemical reaction, reactants convert to product by a chemical conversion, right? Reactant and product totally different. Reactant characteristic totally different from the product characteristics. See, acid base, it's a mineral and water. No acid or base produce, right? That's the meaning of chemical reaction. Okay, now let's see how this chemical reaction take place. Actually, in actual story, how so HCl and sodium hydroxide how convert into sodium chloride? Do you have any idea how it is convert? In molecule level, what happened to them? Now you know HCl contain hydrogen molecule and chlorine, sodium and oxygen and hydrogen. They are molecules. No? they are molecules, right? This molecule combined, they prepare compounds. Now HCl is a compound, sodium hydroxide also compound. Now they are compounds. Then how they, if it is mixing sodium hydroxide and HCl, two reactants A and B, or any two reactants, how it is converted to different product? What is the reason for it? Do you have any idea? Do you have idea? Okay, this is a story, right? That we called as collision theory. That we called as collision theory. That's a concept found by a scientist, right? Okay, this is a theory. This is a story, right? Now think. Let's get same example, HCl, because it is same, it is simple chemical reaction, sodium hydroxide, right? Then it is converted to sodium chloride plus water. They are product, they are reactants. Now if we mix sodium hydroxide and HCl in a one container, in a vessel or system, then what happened actually? Actually, they are hydrogen ions and chlorine ions, Cl minus ions, separate, right? Separate. මෙයාගේ මොකද වෙන්නේ? sodium ions and OH ions separate, right? They are ionized, ionized and ion separated. How it is ion separated? Due to the molecular collisions. Then I will explain in simple way, right? Actually think they are two reactants. This is a one reactant, this is another reactant, right? This is a one reactant, think it is A and think it is B, right? Think it is B. Think it is HCl and sodium hydroxide, A and B, right? When we mix in a container or system, what happened? This reactant molecule start to collide each other. Collide each other means start to collide. Right? Collide each other. Due to that, they are ionized. Their ions separate like this. Separate. They are already available bonds break down and they are separate like this. Methane breakdown, breakdown and breakdown. Due to what? HCl and sodium hydroxide molecules, compounds collide each other, reactant compound each other, right? Due to the collisions, they convert into ions and molecules separate. Actually in molecular level, molecules separate, right? Molecules separated. Api make ions, right? Ions separate. Ions separate. Ions separate. You know, these molecules already, this molecular level, these molecules, sodium, hydrogen, chlorine, this molecule always vibrating, and they have some kinetic energy. Due to that, they always vibrating. Due to that, again these molecules collide each other. Again, meva gatina. Then what happened? This sodium menna me denna. මෙයාලා they producing new bonds between these molecules. They producing new bonds, new bond. Sodium chloride is produced, right? මෙයා ගිහින් combine වෙනවා මෙයාත් එක්ක. Right? Okay, I'll explain that. This is the general idea. General idea. Okay. Now I will explain in details. I got the general idea. Due to the collisions, they separate into molecule, right? This separated molecule again collide each other. Due to that, they produce new bonds between molecule. Then they convert into different new products. Okay, this is actual thing. In molecular level, actual thing. You know, when we mix HCl or sodium hydroxide or any two reactants, two or more than two reactants inside the vessel, what happens? They are molecules, they have some vibration, they have some kinetic energy. Right? In heat lesson, we discuss if you get any solid or liquid or gas or any substance, this molecule has some kinetic energy. Due to that, they vibrate. Okay, when we add two substance, two reactants in a one container, what happen as a mixture? This reactant molecule vibrate and they have some kinetic energy. Okay, due to vibration, what happened? These reactant the bond between each reactant molecule will be breakdown. That means මෙහෙම අපි reactant එකක් ගත්තොත් මෙයාගේ already available bonds break down due to collisions with other molecules, right? Their bond break down and separate molecules, separate. Other reactants also bonds break down due to these collisions, and මේවාල ගැටෙද්දි collisions කියන්නේ ගැටෙනවා කියන්නේ මෙහෙම ගැටෙනවා කියන එක, right? They are breakdown, bond breakdown and molecule separating, right? Molecule separating. You know, these separated molecules also, this molecule separate due to bond breakdown, right? Breakdown bonds. These separated molecules also again vibrate. This vibrated molecule again collide each other. Due to that, they produce new bonds between molecules, right? New bonds, not previous bond. It's produced new bonds. New bonds mean sodium react with sodium combined with chlorine molecules. I got sodium molecule combined with chlorine molecule. New bonds sadagan. New bonds. It's producing new bonds, right? That we call the actual reason is then the actual reason is this chlorine negativity, right? Electronegativity is greater than OH. Therefore, this sodium more prefer to combine with chlorine. Make it in HCl mixture, no problem. Chlorine combine with hydrogen, but if they have sodium well, positivity එක වැඩි, right? It is greater positivity, electropositivity. Due to that, sodium and chlorine combine, right? That's the actual story. That's a general idea. If due to the collisions of molecule, there are already available bonds break down, and this breakdown molecule again collisions, they produce new bonds between molecules, right? These new bonds produce new compounds. They are the products. Okay, this is stored. This is a collision theory. I clear? In doubt? That you should have complete idea about this part, because that's a base of entire lesson. Everywhere on this lesson we discuss in this same thing. Okay, if we summarize me what happened during a reaction, reactant molecule collide each other, right? Reactant molecule collide each other. Again, ගැටෙනවා. They are already available bonds break down, right? කලින් තියෙන bonds break down වෙනවා. And it's produce new bonds between reactant molecule. These new bonds produce new compounds. These new compounds are the product. This is summary. This is summary. Only 3 steps, right? මේ ටික ඕනනම් මම දීලා තියනවාද? However, not when may term එක වැදගත්. However, not all collisions are effective. That I'll explain in the. That means not all collisions produce product, right? That's not all collisions produce product. That was exam question. I will explain. It's very simple thing. I will. Okay. This is the thing. These collisions have the ability to break down already available bonds. Break down already available bonds between molecule and formation new bonds. Formation a new bonds. This is a process of consumption of reactants. Consumption of reactants means reactant concentration decaying. Decaying can another. Decreasing the concentration. Reactant decreasing, and these reactants convert into new compounds. New compounds are the product. These new compounds are the product. These new compounds are the product, right? If you want, I will give you what are the main steps of chemical reaction. Api make a summarize karot. If we summarize this process, the first thing, reactant molecule collide each other. Collide each other. Already available bonds break down. Already available bonds break down. Finally, new bonds forming between molecules. This is a summary. If you want, it's already given, but if you want clear points, they are the you can note down. Complete. Timid. Okay. It's very interesting lesson. No need to buy heart. Everything like a story. Right. Hi. Okay, now let's see what are the requirements to now if it is reactants convert into product, reactants convert into products, what are the requirements? Reactant molecule collide each other and they are already available bond breakdown and formation new bonds between molecules, right? They are the new compounds. To complete this process, this reactant molecule should have three main requirements. Every exam paper, these three factors asked, right? They are the requirements to reactants convert into product. Okay. Okay, let's see what are the requirements. I used to hit this part. Don't worry, it's very simple. In O level, you're not discussing kinetic chemistry, you're doing. Wait a minute. But why can't chlorine go back to hydrogen? What makes sodium better? Yeah, that's the thing. Yeah, after breakdown, මෙයාලගේ තියෙනවා ඔයාලට O level වල කරනවා activation series එකක්. Do you remember? Yeah, sodium positivity is greater than hydrogen, right? Therefore, chlorine more like to combine with sodium, not hydrogen. Hydrogen is combined with OH. Okay. Okay, now let's see what are the requirements. What are the requirements to above process? Now, breakdown bonds and for new bonds formation, what are the requirements? What are the requirements? Hari. Main first one. Make a hamadamahan, right? Every day asking question. Okay, the first thing is reactant molecule collide each other, that you already know. Reactant molecule collide each other. Reactant molecule collide each other mean due to vibrations, they collide each other, right? Collide each other, right? The second one, collide with proper orientation. Again, collide is not enough. Collide is not enough. Collide do not have it should have proper orientation. What's the meaning of proper orientation? Collide with proper orientation. Proper orientation means collide with proper orientation. That means Correct direction. That means proper direction. Proper direction. I will explain what's the meaning of proper orientation. Proper orientation. The final one, factors final one, reactant molecule should have sufficient energy. Sufficient energy. Sufficient energy to participate to the reaction. To participate to the reaction. The level is activation energy. I will explain everything. I will explain. I am explaining the three factors. The limit is activation energy exceed the activation energy. Exceed the activation energy. Activation energy. Activation energy. Okay, now let's go one by one. Okay, they are the main requirement of any chemical reactant molecule to convert into product. To convert in product means they are already available bond breakdown and produce new bonds. For this process, these three requirements must compulsory. Must fulfill these three requirements. Requirements tunama okay window. Right? Must fulfill these all requirements, all three requirements. Okay, the first thing is reactant molecule collide each other. They collide each other, no problem, due to their vibrations. Reactant molecule collide, it automatically happen, right? That one okay. That one okay. All reactant molecule collide each other, that's okay. But if it is collide, if it is not collide with proper orientation, cannot be converted in products, right? Cannot be converted into product mean this bond breakdowning for new bond formation. You can break down නැත්නම් කොහොමත් form වෙන්න බෑ. Okay, for this reactant convert into product process is not possible if it is not collide with proper orientation. Now let's go to the tune to understand what's the meaning of orientation. Okay, they are the three factors, right? I will explain activation and data. They are the three factors: collision, proper orientation, and sufficient energy. Okay, they are the three factors, right? Okay, this is a proper orientation. Now A react with BC, then it is produced AB plus C. Right? This is a chemical reaction. A react with BC. BC is a one compound. May compound. Then it is produced AB plus C. Now think A collide with B side. A collide with B side. Collide, right? Then it is okay. AB produce new bonds. Mayage bond break karana. Right? Due to this collision, BC bond break down, and A and B produce new bonds, and A, B and C produce. Are you clear? Due to this collision, now it is collide with proper orientation. Due to this proper orientation, this C displays mean bond breakdown and remove. A combined with B. Clear? but A collide of opposite side of this this compound. Then what happened? Then what happened? A collide with C side, but C is not producing compound bond with A. Then it's reflect. मैं rejecting. Then no reactants involved for the product formation. No product formation. No reaction. Right? Then real example. Our sodium hydroxide example. Then think like this. Now think they are hydrogen ions, hydrogen molecules, and chlorine molecules. Hydrogen, chlorine. This is sodium hydroxide, right? Sodium, may I sodium hydroxide. Sodium hydroxide. Now this chlorine ion collide of this side. So chlorine ion collide sodium side. Then it is OH displays and removing, and sodium chloride is produced. But chlorine ion chlorine ion react with collide with, it is OH side sodium, then it is produced product. No, this collision is not effective. This collision is not effective. Mehema collide not, it is not validate. I got, it's not producing product. You made clear? That's the meaning of the collision is a requirement, not only collision enough. Collide with proper orientation also very, very important. Any doubt, Safa? I got. Nabil? Get the full idea, otherwise this lesson will be very complicated, right? But this lesson, if you got this today part, Anithika, very simple. If you got the full idea about today, it discussing basic part, next day and final up to final calculation, it is very simple. Okay, now we discuss two requirements. Now, in simply chemical reaction mean reactant molecule collide and they are bond breakdown and producing new bonds. To this process, reactant molecule should have complete three main requirements. The first one, reactant molecule collide. So, collide no problem, due to vibrations they collide each other, but collide is not enough. The collide with proper orientation, proper direction also very, very important. Okay, the final one is this reaction molecule now collide with proper orientation. That one also okay, but they don't have sufficient energy. Sufficient energy mean activation energy. Okay, now let's see what's the meaning of activation energy. What's the meaning of activation energy? What's the meaning of activation energy? Remember, the activation energy, I think 4 or 5 times past papers. The activation energy, what's the meaning of activation energy? Remember, the activation energy means the minimum energy level. The minimum energy level requirement. to participate to the reaction, to the minimum energy level of reactants, that one compulsory reactants at the end only minimum energy level to participate to a reaction, chemical reaction. Okay, this is a exact definition, chemical reaction. Okay, this key terms very important, right? Okay, I'll explain. It's very simple way, right? Mebala. Okay, think A, B, simple example, right? C, D. A, B, C, D. A, B, C, D are four reactant molecules, right? Four reactant molecules. A, B, C, D are four reactant molecules. Think A molecule has five, all, every molecule, they have some energy level. Energy level we have some energy level, right? Same as molecules also, they have some energy level, right? Example, think A molecule 5 joules, think B contains 6 joules, C contains 7 joules, and D contains 8 joules. Think the activation energy for a particular chemical reaction, right? The activation energy for a particular chemical reaction is, activation energy is 7 joule. 7 joule is activation energy. Now, what's the meaning of activation energy? The minimum energy level of reactants. The minimum energy level of reactants to participate in a reaction. Right? The minimum energy level. Participate, that's the meaning. The minimum energy level. If it is not contain this much energy, this reactant molecule collide with proper orientation, not enough, right? They should have sufficient energy up to activation energy or exceed activation energy, right? Now, A molecule collide with D. Is it effective collision? Is it produce product? What do you think? A collide with proper orientation. We know. A collide with proper orientation. Is it produce product? The activation energy 7. It's example, right? Yes or no? No, very good. The thing is, the reason A don't have sufficient energy. D D is not enough. A don't have sufficient energy, right? Therefore, no product produced, no reaction completed. Now A react with proper orientation with B. Is it produce product? No. B collide with C. No, that one also not. C collide proper orientation with D. That one okay. That one okay. That's the meaning of they should have sufficient energy. Reactor molecule should have sufficient energy, right? If not, if it is collide with proper orientation, not sufficient. Not sufficient. Okay, now C collide with D. C and D collide with wrong orientation. Is it produce product? What do you think? C and D, they both have sufficient energy. C and D collide with wrong orientation. Again, side direction is collide direction is changed. Then is it converted into product? No, very good. That's it all. If it is reactants convert into product, this all requirement must complete, must fulfill. Right? All requirements compulsory fulfill. Right? That's why we call requirement to reactant convert to product. Requirement of reactant molecule participate or convert into products. Okay, up to now, okay. Any doubt up to now? Right. Now, this reactant molecule collide with collide with proper orientation. This reactant molecule has sufficient energy for converting to product. That means up to activation energy or more than activation energy. This type collision we called as a special name. These all requirement fulfill collisions. Right? These all requirement fulfill collisions we called as a effective collision. Effective collision. Effective collision. Effective collision. Effective collision. These all requirements completed, fulfilled. Collisions we called as effective collisions. Only the මෙතනින් එහාට අපි effective collisions කිව්වම all requirements fulfilled collisions. Clear? All requirements fulfilled collisions are the effective collisions. Then only effective collisions can produce product. If it is not effective collisions, it cannot be produced product. Okay, this is a summary. If you want anything, you can note down. Wait, I will give you some. I will give you time. Go to tube. I have given everything. Okay, they are the requirements, and if all requirements fulfill, collisions are called as effective collisions. Effective collisions. Effective collisions resulting in the consumption of reactants and products and new product. Yes, they are effective collisions. They are the requirements. These all requirements complete collisions are the effective collisions. I think now you can understand this. I told previous, however, not all collisions are effective. Now you can understand, right? Not all collisions effective. Effective mean not all collisions complete all requirement, right? Okay, now you have full idea. Okay, this is a proper orientation. It's clearly given here. Okay, this is activation energy definition. The activation energy is minimum kinetic energy of reactants to participate to the reaction, right? This is a very long definition. That's the board given definition also sufficient enough. Make them right? The activation energy is the minimum amount of kinetic energy. Kinetic energy means the energy, right? The molecule contain kinetic energy. That collide reactant particles must possess for their collisions to be effective. Collisions to be effective mean cannot in product and successfully produce the chemical reaction, right? If you want, you can note down the simple way. I'll give you. Okay, this page and this page. If you want anything, you can note. I'll give you 1 minute for this page, 1 minute for next page. This one okay? Okay, go to next. The minimum energy level of reactants requirements to participate to a chemical reaction or reactant convert to product, right? So effective collations කියලා ටියුට් එකේ තියෙනවා, right? Effective collation. Minimum energy level of reactants to effective collations. Yeah. Okay. Okay. Second part is done. Okay. We have 15 minutes now. Okay, we can complete, we can start the third part, and the fully third part we can discuss next day. I will introduce the first part and then you can remember these factors and everything. Okay, our next topic is the rate of chemical reaction. That's the final target of this lesson. The rate of chemical reaction. The rate of chemical reaction. The rate of chemical reaction. Okay, now what's the meaning of rate of chemical reaction? Now, if you got any chemical reaction, reactants convert into products, no? Reactants convert into product. Okay, what do you think? What happened to the reactant amount? The reactant amount increasing or decreasing? What happened to the reactant amount? Reactant amount increasing or decreasing with time? Reactant amount? Yeah, the reactant amount decreasing. Yeah, the reactant amount gradually decreasing because they are reactant and convert into product. The reactant amount gradually decreasing. Yeah, that we called as reactants are decaying. Decaying can vaya වෙනවා කියන එක, right? Decay. Reactants decaying and decrease the concern. The reactant amount mean the number of moles in a unit volume. That means concentration, right? Concentration. Then reactant concentration due to the decaying, the concentration decreasing. Right? If you got products are decaying or producing, then what happened to the concentration, the amount in unit volume? That's one increasing. Then it is producing. Due to the producing, the number of matters, amount of matters in unit volume is increasing. Due to that concentration increasing. concentration increasing. Concentration increasing. Right. Concentration increasing. Okay. Then how we can define the rate of chemical reaction? Remember the rate of chemical reaction, main definition nigga. The definition is always asking what's the meaning of rate of chemical reaction. The concentration change of reactants or products. Reactants or product, both correct, right? Reactants or product. The concentration change of reactants within unit time or the concentration change product within unit time. The concentration change of reactants or products within unit time. Within unit time. Okay, within unit time, the concentration change of reactants or product. Okay, that's the meaning of rate of chemical reactions. Separately, I will explain what happened to if it due to the concentration decrease. Actually, this reactant concentration change rate is a minus value that I will explain, right? Product concentration change rate is a plus value always, that we can discuss later in mathematically. You don't need to remember them. Mathematically, we can prove, right? However, now up to we discuss that part after next week. Next week we can't discuss. Next Wednesday we can discuss. Sunday we have factors. There's a third part. Then final part. This lesson only you have 4 parts. Now 2 parts already completed. That we doing third part. Right? Third part is very long session. Next week also we need for this part. Then final part after next week. Then the lesson is complete. Right? It's very short and sweet lesson. But in final part you have very long calculation part. Very important calculation part with expressions. Right. Now what's the meaning of rate of chemical reaction? The concentration. If you got now it's concentration change, concentration decreasing, reactant concentration decreasing, and it's converted into product. Then product concentration gradually increasing. Then we can say the concentration change of reactants or product within a unit time. Within a unit time, how much reactants decaying, how much product producing, right? That's the meaning of rate of chemical reaction. Clear? Rate of chemical reaction. It is already given. Okay, now let's move into final part. Okay, that's the meaning of the the rate of chemical reactions can be defined as the reactants of product concentration change over unit time. The concentration change, this delta mean change, concentration divided by time. Divide by time. Okay, it is given if it is reactant, the decaying rate is minus value. If it is product, it is plus value. I will explain that later. Do you know what is the standard unit for rate of chemical reaction? What's the standard unit for rate of chemical reaction? What do you think? Now, rate equal delta concentration divided by time. Concentration change divided by time. Then what's the meaning of what's the unit of concentration? Last lesson we discussed. MOL Dm minus 3, no? Moles per cubic decimeter. Divide by seconds. Then what's the unit? MOL Dm minus 3 S minus 1. Make a liana better. MOL Dm minus 3 S minus 1. How we pronounce that? Moles per cubic decimeter per second. 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 So is the error after this one? Yeah. මේක දහන්න දෙනොත් මෙතන minus එකද? Yes. Error. Moles per cubic decimeter. Yeah, it's minus 1 is a mistake. Moles per cubic decimeter per second. This is a unit. Yeah. That's printing mistake. Yes. Typing mistake. Yes. Hi. Final part. Okay, today we did very important and very long session. We did 2.5 parts. Final. Okay, factors affect on the rate of chemical reaction. Factors affect on rate of chemical reaction. Hi. Okay, that's our main third part. We need to discuss one by one factors and its effects and everything. Okay, remember how many factors affect on what you think? How many factors affect on rate of chemical reaction? Yeah, lot of factors. Product. Many number of factors affect on the rate of chemical reaction, but we can't discuss one by one every factors. Therefore, for easy study, we can divide these factors into two main types. The first one direct factors or main factors, and indirect factors. Indirect factors. Main factors and main direct factors and indirect factors. Right? Remember, in this lesson, we discussing one by one in details. In depth, we discussing about direct factors, only direct factors. Direct right? The first direct factor is the temperature. Temperature is a main factor effect on rate of chemical reaction. The second factor is reactant concentration. Reactant concentration. Reactant concentration, that means initial reactant concentration, right? Third one, catalyst. Catalyst. Fourth one, reactant. Reactant. Contact surface area. Surface area. Okay, you have note down this. Please note down this chart. If you have tute, you can note down their main factors. It's only 4. They are the extra indirect factors. I'll give you. If you don't have tute, please note down. With I think tomorrow you can collect the tute. Okay, direct factors only 4. They are main factors, mainly involved for the rate of chemical reaction, right? That we can discuss one by one. But not only that, other factors. What are the other factors? Light energy, pressure, and pH level. pH value, that means acid base condition. UV radiation. Not only that, many products, UV radiation, heavy metals. Light, pressure, pH, yeah, that's enough. Okay, we're not going to discuss indirect factors in this lesson. Main factors only we discussing one by one in next day. Okay, next class, very important. We discussed how temperature involvement and what are the effects, how concentration involvement and what are the effects, catalyst involvement and what are the effects, and contact surface area involvement and effects. Okay, note down this, and this is the today lesson. Okay, this is our next day first topic, the temperature effect to the rate of chemical reaction. Okay, that's the end of basic and very important topic parts of kinetic chemistry. Okay, do you have any doubt? Now you can ask. Everything okay? Okay, then again go to this part within today. Again go to this part and try to revise again, right? Otherwise, the next day we discussing this each factor how involved for above story. Two molecule collide and they are bond breakdown and produce new bonds. How this process change with temperature. Then if you have full idea about the previous story, then very simply you can understand temperature, this factor effect, and it is very helpful for our final calculations as well, right? Okay, then go through and try to get the full idea. Don't by heart them. Don't try to by heart theory, right? Try to understand as a story, right? You can use different diagrams and charts. Anyway, try to get the story and the concept, right? Okay, then good night. Let's meet again Sunday. After that, every Wednesday you have class, right? Goodbye.